This video is explaining how we're going to get the ordered pairs for the unit circle, using triangles. So in class I said we went through the derivation, so that's what I'm going to do in this video, is go through the derivation on the points. I do want to preface this by saying that you won't need to know how to get the points. Like everything we do today is, you won't necessarily need to know it. You will need to know the actual points, but you won't actually need to know the derivation. I wanted to go through this though, so that we can see that these points actually do come from somewhere. So that's what we're going to do here. So we'll see where these points come from. So let's start with 45 degrees. So if we look at 45 degrees, and if you have your unit circle, go ahead and take that out. And we're going to go through, we're going to add to it today. But here we're at 45 degrees. So what this is saying is, if I draw the radius going out to this tick mark, then that is a 45 degree angle. Now, our goal today is to figure out, what is this point? What's the ordered pair for that point right there? And we can actually figure that out. So if you think about this, this is on the XY plane, okay? If I can figure out, starting here, if I go to the right, how far right to go, that's going to tell me my X coordinate. And then from here, if I can figure out how far up I go, that's going to give me my Y coordinate. And what's happening is, basically we have a triangle, and we're trying to solve for these two sides. Now here we're in luck, because if this is 45 degrees, this is 90, that means that this one also has to be 45 degrees. So we're dealing with the 45, 45, 90 triangle. And the reason that's helpful is because if these two angle measurements are the same, then what we talked about in class is the sides that are opposite of those angle measurements are also the same. So if I were to label this side A, then we know that this side is congruent, or the same length, so we can also name that A. Whatever this value is, that's going to be the exact same value. Another thing we know about this triangle is it's the unit circle, like a singular unit, which means that our radius will always be 1 in terms of from the center going out. Our radius is always 1. Because we're dealing with the unit circle. Now our goal is to solve for A. If we can solve for A, then essentially that would give us the X and the Y coordinate. And what we said in class is, we have a triangle, we know the three sides, we can use the Pythagorean theorem. So the Pythagorean theorem says this. That's what Pythagorean theorem says. But in terms of our triangle, A and B are both going to be A, because we're dealing with the legs of the triangle. So we could say that this is A squared plus A squared equals, and our hypotenuse would be 1. On the left-hand side, we can combine like terms and say that that's going to be 2A squared. 1 squared would be 1. And then in class, I let students solve for A. But if we solve for A here, then we could divide by 2. Now we want to take the square root to get rid of the square. And we get A equals the square root of 1/2. But we don't want to leave it like that. So if we have square roots, or square root of a fraction, we can take the square root of a fraction by doing square root of the numerator over square root of the denominator. And we can always simplify, or not always, but we can simplify this one. Square root of 1 is 1. The square root of 2 does not come out as a whole number, so we'll leave it as the square root of 2. Now, and a long time ago, for whatever reason, mathematicians they, I guess, convened and said, we don't like radicals, we don't like square roots in the bottom of a fraction, in the denominator. So what we're going to have to do here is what we call rationalize the denominator. And in order to rationalize, we're going to multiply the top and the bottom by that square root. And the reason this helps is because now we have a equals 1 times the square root of 2 would just be the square root of 2. I'm going to do this up here. Square root of 2 times square root of 2. Really, if we have two radicals and we're multiplying, it's the same radical, the radical stays and we can multiply what's under, so that'd be square root of 4, which we know is just 2. So our denominator here becomes 2. And so what this is telling us is, again, if you need to pause, rewind, please go back and do that. If you have questions about anything, find me at school and I can answer that. But a here is square root of 2 over 2. This a is square root of 2 over 2. And so our xy coordinates at 45 degrees or at pi over 4, because that's the radian measure, is square root of 2 over 2 comma square root of 2 over 2. So this is great because we were able to put that on our unit circle at that ordered pair for pi over 4 and add that to it. And this is showing us where the actual ordered pair is coming from. Okay. Now, again, I'm not going to ask you, this will not be asked of you, but the beautiful thing is that we have this ordered pair, and we're going to see why that's a beautiful thing, talk about why that's a beautiful thing in the next video.